Hello, my dear students. It's my pleasure to meet you today. Today, inshallah, we are going to study the trig 2 lessons. We have remaining 2 lessons, which solving triangle and application on it, which is angles of elevations and angles of depression. Okay, let's concentrate here. First example, trig. If we have an example here, solving the right angled triangle. We will solve right angled triangle. What is the meaning of solve right angled triangle? Any triangle here has 6 elements. What is the elements of triangle? If we have triangle, okay, okay. Yes. اوكي بس انا هبص على دي. Okay. We have a triangle A B C. Okay. Solving right angle triangle. What is the meaning of solving right angle triangle? This is acute angle triangle, but if we have a right angle triangle like that, and ABC is a right angle triangle at C, A, B, C, okay. This right angle triangle, we have here 1, 2, 3 sides and 1, 2, 3 angles. So we have 6 elements. To solve the triangle, we must find the 6 elements. Normally he give us 2 elements plus the right angle, and we supposed to solve the triangle and find the remaining elements. As here, example ABC is right angle triangle at C, so C is right angle, in which AC equals 8 centimeters. AB here, sorry, AC is 8, but AB is 12.5 centimeters. Okay, to solve the triangle, we must find the third side and find this angle and this angle. Okay, to find the third side BC, if we have right angle triangle at C, then we will applicate the Pythagoras theorem. We calculate this, BC power 2 equals AB power 2 minus AC power 2. So we will find BC equals square root. AB power 2 means 12.5 all power 2 minus 8 power 2. So the answer will be 9.6 centimeter. Okay, so we have BC here equals 9.6 centimeter. Okay, and also we will find the angles, the angle A and the angle B. How can we find the angle A and the angle B? Starting with the angle B, and we have opposite here, and we have a hypotenuse here. We will say that sine the angle B equals opposite over hypotenuse. Opposite here is 8 and hypotenuse is 12.5. So to find the angle B, we will use calculator and press shift sign. We will press shift sign this fraction. Okay, 8. Yes, equals. So the answer will be 39 degrees 47 minutes and 31 seconds. And also we can find the measure of the angle A. We know that the sum of angles of triangle equals 180 degrees. So we can put here 180 minus 90, which is C, plus 39, 47, 31 degrees, minutes, seconds. And the answer will be 50, 12, and 29. 50 degrees and 12 minutes and 29 seconds. So we have here the solution of triangle. At first, he gave us the side CB, the other side AC, and we have a right angle. So we have read 3 elements of triangle. To solve the triangle, we must find the other 3 elements, which is the side. Here, we can express it by another color. BC, this one, and the angle A and the angle B. And we have done BC equal 9.6 centimeter. The angle B is 39, 47, and 31. The angle A 50, 12, and 29. Okay. We will move to another example for you, how to solve a triangle if we have 2 angles and 1 side. Okay, this is a triangle here. ABC is a triangle. The measure angle B equals 90. So we will draw a right angle triangle here. B here is right angle triangle, and we have A here and C there. And we have AC equals 12.5 centimeters, and measure angle C is equal to 25 degrees and 50 minutes. And we want to solve the triangle. Okay, to solve the triangle here, we must find the measure of the angle A. Okay, to find the measure of the angle A, we will applicate the rule that measure angle A equals 180 minus the sum of the other 2 angles, which is 90 plus 2550. By using your calculator, you will find that the answer will be 64 and 10, 64 degrees and 10 minutes. Okay, so we have this angle 64 and 10. Okay, to find the other elements, we have a side here which is hypotenuse 12.5. To find another side which is AB as example, we will use this angle. This angle, its sign will be opposite over hypotenuse. So sine 2550 equals AB, which is opposite, over hypotenuse, which is 12.5. So AB will be equal 12.5 times sine 2550 So AB will be equal, you can use your calculator, and the answer approximately equals 5.45 centimeter. Okay, so it's here 5.45 centimeters. To find CB here, we can applicate Pythagoras theorem. CB equal square root of hypotenuse power 2, which is 12.5 power 2, minus 5.45 power 2, and CB will be approximately 11.25 centimeter. Okay, we have now the three sides. This side, which is given, AB, we calculated 5.45, and CB is 11.25 centimeter, and we have measure angle A 64 degrees and 10 minutes, and already we have measure angle B equal 90, measure angle C as a given 25 and 50 degrees. Okay, we will have another example here. My dear students, you learn now that if we want to solve a triangle, we must find all elements of triangle. He gives you three elements, which is right angle triangle, and two other elements, and you must find the other two elements. Okay, let's see this example for you. If we have a triangle here, ABC is a triangle in which measure angle B equal 58 degrees and 12 minutes, and BC equal 15. Draw AD perpendicular to BC. So the triangle ABC now is not mentioned that it's right angle triangle, so it's say acute angle triangle, and we will draw AD perpendicular to BC, and D belongs to line segment BC, and he gives us that AD equal 10 centimeter, so the request is find to measure angle C. We have here a triangle like that. We have a triangle ABC. We drew triangle. He didn't mention that it is right, so we will draw it as an acute angle triangle A, B, C, and he gives us the measure angle B equals 58 degrees and 12 minutes, and BC equals 15 centimeter. Draw AD perpendicular to BC. We must draw a perpendicular here from A to BC. Okay, like that. So we have AD here is perpendicular to BC. Okay, so we have a right angle triangle ADB and another right angle triangle ADC. Okay, BC here is 15 centimeter, and AD perpendicular to BC, as he said, D belongs to BC. Okay, if AD equals 10, here AD equals 10 centimeters. Okay, so we have the angle B, we have the angle B here equals 58 and 12, not the angle A. The measure angle B equal 58 and 12 degrees. Okay, we have here AD equals 10 and measure angle B equals 58, 12. So to find the angle DB as example, we will learn about cosine angle. Okay, cosine angle here, we will deal with cosine triangle ABD, cosine 58 and 12 equal DB over 10. Okay, we have here AD equals 10, so it is not cosine, it's tan. It's tan. Tan 58 and 12 equal AD. Sorry, we'll start in triangle ADB. We have the angle B, measure angle B here, equal 58 and 12. So tan B equals opposite over adjacent, which is AD, which is 10, over DB. We here have CB as X, as 15, and if we put this X, then CB will be 15 minus X. Okay, I think something wrong with this question, so we will change it quickly. Look here to the another example here. We here will find, sorry about the example, something wrong with the given, so we'll change it now to another example. We will succeed about or discuss about the angles of elevation and angles of depression. What is the angles of elevation and angles of depression? We have, if we have a house, okay, if we have someone here, look at a house here, okay, and someone here, look using his eyes to the top of a house or anything here. So we will draw a right angle triangle, and this angle will be the angle of elevation. So again, if we have a tower or a house here and someone here in the street looking to the top of this house or this tower, so this angle which gives us with horizontal is angle of elevation. Okay, but if we have someone here on a top of a tower or a rock or anything high, and he look to something here in the ground, so we will draw the angle of depression as this one. Here the angle of depression will be this angle. Okay, but we know that these two sides are parallel, so this angle equals this angle alternate. Okay, we have here a right angle triangle, so this angle is the angle of depression. Okay, and this angle equals this angle by alternate because these two sides are parallel. So when someone here looking for something here, there, up, it's angle of elevation. But if the body here or someone here looking at something in the ground and he is on a top of a tower or a rock or anything high, so he looking there to something in the ground, so this angle will be angle of depression, which is equal to this angle, and we have right angle triangle here. And using the solving of right angle triangle, we will get the unknown which he want to be. We have here an example directly. If we have a man, okay, here, a man found that the measure of the angle of elevation of the top of a house at a point equal 50 meters. So we have a man and he looking up, so it's angle of elevation of a top of a house. So we will draw here a house, okay, and a man here looking at the top of the house here, and this is the ground, and we have here a right angle triangle, and we can say this A, B, and C. And the angle of elevation, a man found that the measure of the angle of elevation of the top of a house at a point 50 meters far from its base. Here, the man standing here at 50 meters far from the base of the house. So CB here equal 50 meters, and the angle of elevation here 38, 26, 38 degrees and 26 minutes, okay. And the request is find the height of the house to the nearest meter. So the height of the house is unknown here. To find the height of the house, we will deal with this angle, this side and this side. This angle here is 38, 26. We will ask ourselves, we will use sine, cosine, or tan. This angle here, we have opposite, we need it, and adjacent, we have it. Opposite and adjacent, we will use tan. So tan 38, 26 equals opposite, which is AB, over adjacent, which is 50. Okay, so to find AB, it's 50 times 10, 50 multiplied by 10, the angle 38, 26, and by using your calculator, you will find that the answer okay, you can use a calculator, we will not use it now. Okay, so you can calculate and find the answer. Okay, we can, okay, I'll find it for you. 50 times 10, 38 degrees and 26 minutes equals, the answer approximately equals 40 meters. Okay, so the answer equals 40 meters. So the height here of the house, the height of the house AB here equals 40 meters. It's really 39.6 and something else. To approximate it, okay, 39.6, but to approximate it to the nearest meter, we must approximate 6. Here, if it is 5, 6, 7, and 9, 8 and 9, we will add 1, so it is 40 meters. So the height of this house equals 50 meters. Okay. 40 meters, sorry. We will have another example about angle of depression this time. Okay. From the top of a tower of height 50 meters. So here we have a tower and its height equals 50 meters. And this is the ground, of course. The measure of the angle of depression. The angle of depression here is this angle, which is what? The measure of the angle of depression of a body in the same horizontal plane with the base equal 23 and 24. 23 degrees and 24 minutes. And of course, this angle is right angle triangle. Find the distance between this body and sorry, the base of the tower to the nearest meter. Okay, so we have here this angle and the opposite side, and we want to find the length of the base. Suppose that is A, B, and C. To find the length CB here, we have this angle. This is the opposite, and this is adjacent. And we know that the trig function which deal with opposite and adjacent is tan. So we write tan 23 and 24 equals opposite, which is 50, and adjacent, which is CB, and we don't sorry, we don't know what is the length of CB. So CB here equals 50. Okay, 10, 23, 24. So we can calculate CB. It will be approximately 116 meters. Okay. Okay. Okay, my dear students, give us some break and we'll return again. Hello, my dear students. Hello again. We will return to discuss our angles of elevation and angles of depression of trig lesson. Let's move to another example here. We have example number 3. Here we have a man of height 1.5 meters. So we will draw a man here of height 1.5 meters. Was standing on the ground. Okay, so it's the ground here at a point which is 10 meters from the flagpole. So we have here a flagpole and it's far from it by 10 meters. Okay, he found that the measure of the angle of elevation. Okay, what is the angle of elevation here? Here he will put his eyes there, and the angle of elevation will be this angle. Okay, what is this angle? This angle is 40 degrees and 22 minutes. Okay, the angle of elevation of the top of the flagpole is 40, 22. Find the height of the flagpole to the nearest meter. So we would like to find or calculate this flagpole. Okay, let's name these points. We have here A, B, C, D, and E. We have the height of the man 1.5 meters. So CB equals 1.5 meters also, because we have here right angle triangle. This is the horizontal and this one is the horizontal. So EBCD is a rectangle. So BC equals ED equals 1.5 meters. And DC here equals 10 centimeter. And of course EB here equals 10 meters also. And this angle will be right. Okay? And we would like to find or calculate the length of AB. So in the right angle triangle ABE, we have this angle. EB, its adjacent, is 10 meters. And AB is the opposite angle. So we will calculate tan, the angle 40 and 22 equals the opposite, which is AB, and the adjacent, which is EB. AB here is unknown, but EB is 10 meters. To find AB, multiply 10 by 10, 40, 22. So the length of AB equals approximately 8.5 meters. So here AB equals 8.5 meters. Okay, so the total length of the flagpole here, which is AB, equals 8.5 plus 1.5. The final answer will be 10 meters. So the height of the flagpole here equals 10 meters. Let's move to another question. We have here another question about height of a pole. Okay. A light pole of height equals 7.4 meters. So we can draw the light and put its height is 7.4 meters. Gives a shade on the ground. So the ground is here. Okay. Gives a shade on the ground of length 5.55. If we have a shade, then of course we will have a sun here. If we have a sun here, and this is the light, and give a shade of 5.55 meters, and if we draw this line, we will complete a right angle triangle, and we can name these points as A, B, and C. Find what? Find in radian. Okay, the measure of the elevation angle of the sun at that moment. So we have here the elevation angle, and we would like to calculate it. So we want to calculate the angle. What about this angle? This angle here is the angle C, and we have opposite side, which is 7.4, and adjacent side, which is 5.55. So opposite and adjacent. It's easy to use tan. The angle C equals 7.4 over 5.55. So to find the measure angle C, we will calculate it by using the calculator. You press shift, then tan, then you write the 7.4 over 5.55, then you press equal, then you will find that the angle will be 53 degrees, 7 minutes and 48 seconds. But do not forget that he wants you to find the radian measure. This is the degree measure. Do you know the how to convert from degree to rad? If we have degree here, to find theta rad, you must put theta degree times pi over 180 degrees. This is the rule. And by applying this rule, the theta rad or the angle C will be equal 53,748 degrees minutes seconds multiplied by pi over 180 degrees. And the final answer will be 0.927 rad. Okay, so it is the radian measure. To find the radian measure, theta degrees times pi over 180. And the opposite, if we want here to calculate degree measure, we will put here theta degree, and this is theta rad, multiplied by pi 180 over pi. Okay, so here we will have calculate the measure angle C in rad measure. This is the measure of the angle C. Okay, let's move to another example. Remember the difference between radian and degree measure. Degree, we use degrees, 50, 70, and the rad, use the rad, which is about circle, and we have studied it in the first term about how to calculate it in rad. Okay, let's move to the following example. We have the example number 5 here. Sorry. From the top of a rock, so we have a rock here. Okay, imagine that is the rock of 50 meters high. So its height here is 50 meters. The measure of the angles, two angles of depression of two sailboats. So we have here two sailboats, and this is the sea level. We have a rock here, this rock of height 50 meters, and we have two angles of depression of two sailboats are 32:10 and 49:30. So choose with me which of these two angles will be 32:10 and 49:30. Of course, this angle which far from the base of the rock is the smallest angle, so it's 32:10, because if we look at something far, you will need to raise your head forward or up very much, so the angle will be small here. But here we have the angle is 49:30, and this is of course right angle triangle. We have drawn this figure, and we have two angles here. Find what the distance between the two sailboats. So we want to find this line segment length. If we name this point will A, B, C, and D, and DC here is the request. Okay, and we have only 50 meters and right angle. Okay, first we will deal with triangle ABD. What about this angle? This angle here, and we have the opposite, and we would like to find the adjacent, which is CB. So we will calculate the tan. Tan 4930 equals opposite, which is 50, over CB, which is unknown, and CB now equals 50 over, by using cross multiplication, okay, 50 over 10, 4930. By calculating this, you will find CB equals approximately 42.7 meters. Okay, we will have now CB equals 42.7 meters, and we will deal with triangle ABD. Some people say that why can't we deal with the triangle ACD? You cannot deal with this triangle because it is not right angle triangle, and your studying depends on only right angle triangle. So we must deal with triangle ABD to find BD, and we have the length of BC. By subtracting, we will get the length of DC. So to find the length of DB, we will deal with this angle, and this angle we have a opposite angle here, which is 50, opposite side, and we have adjacent side, which is unknown, which is DB. Okay, so tan the angle 3210 equals opposite, which is 50, over adjacent, which is DB. So DB, when the unknown here in the denominator, we will directly divide numerator, which 50 over tan the angle 3210. So DB here equals approximately 79.5 meters. Okay, and to find the length of the line segment DC here, we will subtract the length of PD and the length of CB. So DC equal, let us calculate it here to see it. DC equal 79.5 minus 42.7. So DC equals at the end approximately 36.8 meters. Okay, let's revise again. We have a rock here, someone in here in the top of the rock looking to two sailboats. These two sailboats with two different angles of elevation. The smallest one will be here because you can raise your head to see the top, but you cannot raise it as this one. Okay, so the angle here is small as this to the angle here, and we deal with triangle ABC first to find CB, and we deal with the triangle ABD to find the length of DB, and by subtracting we will find easily the length of DC. Let's move to the next example here. We have a big example for you. Okay, a ship approaches a lighthouse. Okay, ship approaches a lighthouse of 40 meters high. What is 40 meters high? The 40 meters high is the lighthouse. We know about when we on the sea, to find the beach here, or the place that we will get in the ground here. we have a lighthouse like this, and its height will be 40 meters up to the sea level. At a moment, it was found that the measure of the angle of elevation, angle of the top of the lighthouse, is 0.12 rad. So here, this angle will be 0.12 rad, not degree. Okay. After 5 minutes, okay, it was found that again that its elevation angle measure is 0.24 rad. After 5 minutes, it approach the lighthouse. They found that the angle of the elevation here is 0.24 rad. And don't forget that the time from this point, we can name the points. We have here A, B, C, and D, and he moved from D to C in 5 minutes. Okay, so we have 5 minutes as a time. Okay, we have here two angles and opposite side, which is AB, and we have, of course, a right angle triangle, and we would like to calculate what? Calculate the uniform velocity. Oh, the velocity of the ship. We have here ship, it or its driver here. Look at the light. He found that its angle of elevation equals 0.12 rad. After 5 minutes, which is time here, we have C, the point C, angle of elevation here equals 0.24, and he wants to find the uniform velocity of the ship. Okay, someone says that that's physics about how to find the velocity of or the speed here. To find the speed here, which is v, example, you have to find distance and divide it by time. So if we succeed to find distance dc here and divide it by the time, which is 5 seconds, then we will get the uniform velocity. We will start in triangle ABC here, triangle ABC. Okay, we have the measure angle C, ACB equal 0.24 rad. So tan this angle, tan 0.24 rad equals AB, which is 40, over CB, which is unknown. So CB equals what? Equals 50. Okay, 40 or 50? 40. Okay, so it's 40 over 10, 0.24 rad. The answer will be approximately 42.7 meters. I know that someone asked me, what is this? It's a rad. How can we find 10 rad measure? It's easy for you, but I will explain it to you. To find the rad measure, let's concentrate first here. We have 0.12 rad. We have two methods to calculate tan this angle. First, you have to convert the calculator to rad, okay, and write it tan this angle directly. The second method, to convert it to degree. To find the theta degree will be equal 0.12 rad multiplied by 180 over pi, and then you will find that theta rad, theta degree equal an angle, and you put this angle instead of tan 0.12, you put it tan this resulted angle, which is, a second with me, 0.12 times 180 over pi, okay. The answer will be 6 degrees, okay, 52 minutes and approximately 32 seconds. So to calculate the angle or to convert from rad to degree, you have to multiply 0.12, which is rad, by 180 degrees over pi, and theta here will be 606, 52 and 32. Let's complete the example here. We can find the answer. CB approximately equal 42.7 meters, and we will deal with the other triangle, which is ABD. ABD here, we will find BD. We will find it using this, we deal about this CB, not CB is DB, okay. We used 0.12, so we deal with triangle ABD, so it's BD. So here BD will equal 79.5, and this is a triangle ABD, of course, and we will deal with this triangle ABC. We will find that CB equals what? Approximately 42.7, and after that, by subtracting DB minus CB, you will find that DC equals 36.8 meters. And to calculate the velocity, as we said, velocity here equal distance, which is 36.8 over 5 minutes, okay. You can calculate it using calculator. 36.8 divided 5 minutes equals approximately 7.36 meter per minute. Approximately 7.36 meters per minute. So we answered this question. Okay. My dear students, we have finished this example now, and we have finished our curriculum, and of course we have finished the whole curriculum that you have. We have finished geometry, we have finished trig, we have finished the geometry, trig and algebra, and next time inshallah we are going to take some revision on the new term. Okay, thank you, be happy and be safe, stay home, goodbye and good luck.